So when finding the area of your rectangle, the main thing you're going to want to know is its formula. What's the area formula for your rectangle? And that's going to be A for area equals length times width. A area equals length times width. This means if you want to find the area of your rectangle, you need to find its length, its width, and then multiply them together. But what is the length and width of a rectangle? Well, the length is going to be a side and the width is going to be another side. But which sides do they belong to? Well, for this formula, it really doesn't matter which side is your length or your width as long as the two sides you choose are adjacent. Now, what does adjacent mean? Adjacent just means they're next to each other. So these sides are next to each other. These sides are next to each other. These sides are next to each other. And these sides are next to each other. These sides are not next to each other. And these sides are not next to each other. So if you're going to choose length and width for your rectangle, mainly for this formula here, this is probably not going to be true for other examples, but mainly for this formula, you just want to focus on adjacent sides. If this is going to be your length, then this is going to be your width. You don't want this being your width over here. That's not good. These are not adjacent, so you don't want that. Likewise, if this is your length, you want this to be your width. You don't want this to be your width if that's your length. That's not good. These are not adjacent. So, for the purposes of this formula here, we're just going to choose what makes sense for this rectangle. So let's say we know that the length of this rectangle was 6 and the width was 4. Now, which one's bigger, 6 or 4? 6 is going to be bigger. Now, which side is bigger for this rectangle? This side is going to be bigger. So I would say that this is your length for this rectangle, and this would be your width. And of course, because it's a rectangle, we can fill in all the sides. Now, our area formula tells us in order to find the area for this rectangle, we take our length and multiply it by our width. So our length is 6. So we're going to replace that 6. We're going to multiply by our width of 4. That was an ugly looking 4. Let's try that again. 4. However, that's not all we want to do here. We got something else we got to do. If you recall, for perimeters, we had units. So we're probably going to put units back in for your area. So let's say this was 6 inches and 4 inches. Now we have units everywhere. And I always put that too close. So 4 inches. Now we have this. And if we were to multiply 6 times 4, what will we get? Well, this is going to be 24. Now, unlike what we did for perimeters, we don't want to just leave it as the same unit that we started with, because area is going to be a little bit special. If you have inches, your final formula is going to require you to have your inches squared. Your units have to be squared for your area. That's different from what we did in perimeters. Your units were the same. You started with the same unit as you ended with perimeters, but for area, you're going to have to square the unit that you started with. So if we start with inches, we're going to end with inches squared. If we start with feet, we're going to end with feet squared. If we start with centimeters, you'll end with centimeter squared. So whatever your units are, you got to make sure that you're squaring them. You're adding this little 2 here at the very top corner of your unit. But this is your area. Let's get another example in where we can use our area formula for a different looking rectangle. So let's say we have a rectangle that looks like this now. And our length and width are different now. Let's say we have a length of, let's say 5. Let's say we want meters. 5 meters and a width of 10 meters. So which side would be our length and which side would be our width for this rectangle? Well, this side is a little bit bigger than that side, so let's call that our width, and let's call this our length, right? And you have your units for each side. If we want to find the area for this rectangle, our area tells us to do length times width, which means our area is going to be 5 meters times 10 meters, which 5 times 10 is going to be what? That's going to be 50. But do we just have 50 meters? No. Whatever unit we're starting with, we want to square that for the area. That's going to be a meter squared. So this is how you find the area for your rectangle. If you can remember this simple formula of length times width, you are pretty much all the way there. Just don't forget that your units also have to be squared, and you got it. And of course, don't get hung up on which one's length and which one's width. As long as they're adjacent, it's fine. So even if you swap these, let's say you had your length, right? Let's say your length was here at 5 and that was 10, and this was 5 and that was 10. Now it may not look correct as far as the rectangle, but the math is going to work out the same way. Whether you do 5 times 10 or 10 times 5, you're going to get the same answer. So this formula doesn't really care which order you choose them, but your picture will look a little bit weird. And of course, we don't want that. So now that we talked about the formula and how we're actually going to find the area, let's talk about why this formula works the way it does. Let's say we have this rectangle here. Notice that we have one side is going to be 3 feet and another side is going to be 2 feet. Now, we don't have to fill in the rest. We understand that the rectangle is going to have the same sides, you know, from opposites, right? So this is going to be 3 and that's going to be 2. We don't really care about that because remember, our area is only looking at length times width. If we know the 2 adjacent sides, that's all we're going to really care about for this formula. So we have 2 adjacent sides. Good. But now we want to know why this formula works the way it does. We're told to multiply our adjacent sides. But why? Well, let's look at it this way. When we have this rectangle and we say that this is 3 feet across, right? And this is 2 feet down, let's say we say it that way, we're really just doing this. We're cutting this into 2 pieces because it's 2, and we're going to cut this into 3 pieces because that's 3. And that's going to result in some boxes inside your rectangle. Now, each of these boxes is going to be 1 by 1. Going to be squares here, 1 by 1. So the length and the width are all going to be 1, and it's going to be the unit that we're caring about, right? So this is 1 feet, 1 feet, 1 feet. All right. Good. And if we were to find the area for this little rectangle here, this little square here, we would have 1 feet squared. So the area for one of these is 1 foot squared. However, how many do we have? We have more than just one. We have 1, 2, 3, 4, 5, 6. So if all of these have the same exact area, what are we actually doing here? We're simply adding all of these up. So if you know the area for this, and you're trying to find the area for the entire rectangle, add up all these little squares, which is going to be 1 plus 1 plus 1 plus 1 plus 1 plus 1 gives you 6. And of course, we're going to keep the same unit because we're adding this time. All of these have a feet squared. All of them have a feet squared. So this is going to be 6 feet squared, which would give you the same thing if you had this area, length times width. That's going to be our 3 times 2. Let's put our units in there to be good. 3 times 2, which is going to give you our 6 feet squared. So the reason this area formula works the way it does is because you're really just saying count how many 1 square unit blocks we have. And to do that, you would say, well, this is a 3 by 2. So you can have 2 blocks 3 times, 2 blocks 3 times. So that's going to give you a total of 6 blocks. 2 of these blocks, 3 different times, gives you a total of 6 blocks. Let's look at this again for another example. Let's say instead of having just 3 by 2, we had something a little bit bigger. Let's say it was a 4 by 3. Let's say 4 by 3. So we want it to look a little bit like this. It was a 4 by 3. So 4, 3. And this is going to be now centimeters. This area was going to say 3 times 4, right? 3 centimeters times 4 centimeters. 3 times 4 was 12. We have centimeters squared. So our area is 12 centimeters squared. But how does it look? Cut this into 3, cut that into 4. So we have 4 pieces here. So 1, 2, 3, 4, and 3 pieces. 1, 2, 3. And if each of these are 1 centimeter squared, I'm not going to write it in for all of these, but each of them are 1 centimeter squared, how many blocks do we have? Count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12. Adding all that up, if each one is 1 centimeter squared, you're going to have 12 centimeters squared totally. That's why our area formula works. But of course, you don't want to have to do this every time you're trying to find the area. So this is a nice short way of finding it out. Well, thank you for watching. I hope you learned something today. And if you did, be sure to leave a like and hit the subscribe button. See you again next week.